Hi friends, good morning to everyone. Uh, Today I am here to explaining about the Hall effect. So it is for final year students. It is this topic come under the free electron theory chapter. In last class I always explained about the properties of free electron theory and derivation on thermal conductivity and electric conductivity, and also explain about the failure of free electron theory. Now I will start in extended part, that is semiconductor. So in semiconductor basic idea you already know about that very well, but I will realize those things what you know. So solids or metals you are classify on the basis of conductivity and resistivity, and also we can explain on the basis of energy bands. Basically two bands you are using to classify the solids or metals. So those are valency band and conduction band. So in conductor, the valency band and conduction they are overlap each other. There is energy gap is zero. So conductivity is easy high and resistivity is very low. So these all basic things we know. Next is insulator. It is a large energy gap. So conduction band, valency band too far distance. So it cannot jump from valency band to conduction band easily. So it is not helpful for the conductivity. Next one is semiconductor. In semiconductor, the name itself tells it both character, that is dual character. If you give any voltage or if you give increase the temperature, it act as a conductor. If you are not supplying any voltage or not giving any temperature, it acts as a insulator. So these basic things. And also after further classify the semiconductor, that is eccentric semiconductor and eccentric semiconductor. So eccentric semiconductor is a pure semiconductor. You all are know why? Because you don't use any doping. Why? What is doping? So doping means process of adding the impurities. So pentavalent and trivalent, if you add the pentavalent to the pure semiconductor, pentavalent means the valence electron is 5. So in trivalent means it consisting of 3 valency electron, that is trivalent. So semiconductor example is germanium and silicon. So it consisting of 4 electrons in valency band, that's why it is a tetravalent. So these are basic ideas. In eccentric semiconductor, it is a impure semiconductor because here you are going to dope to the pure semiconductor. If we are adding the pentavalent impurities, that is a n type. If adding the trivalent element, it is act as a p type. So these all are basic things. I don't interested to take too much time to explain these topics. It is a basic, if you when you are studying easily we can understand. Now I will going to start about one of the most important topic in this chapter is Hall effect. So Edwin Hall, he discovered the Hall effect in 1879. According to him, his statement, his property or its principle, what he is going to say is that if magnetic field applied perpendicular to current carrying a conductor, voltage or potential difference is developed perpendicular to both current and magnetic field. So this phenomena, this process is called as a Hall effect. What is the voltage? What is the potential difference is developed? That voltage we can call it as a Hall voltage. Are you getting or not? I will explain once again how this statement is. If you do not getting the knowledge about the statement, so need to so I will not extend this topic. So once again I will repeat how this statement is come. I will take one rectangle. Oh, this is a specimen. It is a semiconductor. It is a conductor. So I will connect both end of this specimen through battery. When we on the battery, current is flowing through this conductor, this specimen. So after that, if both of this end, front face and back face, there is no any voltage is developed. So when your magnetic field is applied, when the magnetic field is applied, automatically there is a voltage is developed. This magnetic field I applied perpendicular to this conductor. When current is carrying here, so magnetic field is applied, automatically there is a voltage developed. That voltage is measured by connecting the voltmeter. So this is the statement. How this voltage will develop, you can, there is a question is arise on your mind. According to Lorentz force, according to you know about the direction of flow of current and magnetic field and force, that is Fleming left hand rule. I will, if you want to know about more about, we can just basic idea about the moving charge chapter, just study about that. What I will going to explain about. When current carrying a conductor, it is placed on a magnetic field, it experiences the magnetic force. Are you getting my point? Any current carrying a conductor placed in any magnetic field, or any magnetic field placed under the current carrying a conductor, this current carrying a conductor experience the magnetic force. It will be deflected. It is curved. So this today here, that's why we get the voltage. How? I will explain. Let us assume it is a specimen. Here I connected horizontally, or x-axis direction I connected the battery. After that, if we apply the magnetic field here, or north and south pole, magnetic field is arranged in both ends. So automatically there is a voltage is developed. That's why I connected in this front face, and back face connected the two terminals through voltmeter. We get the deflection, we get the voltage. So how this voltage comes in your you getting the question, because when the battery is connected here, the current is flowing, so electrons are drifted. We know always electron average drift velocity, the average velocity, they are drifted towards the positive terminal of the battery. So electrons is moving. So when the magnetic force is experienced by this charge particle, it is deflected here. So electrons are moving here. Automatically here positive charge will be, another side will be arises or obtained. In negative charge particle is arise. So both two fields will be getting. So if you want to connect the voltmeter, we get the potential difference. There is a electric field will be generated. Magnetic field and electric field. So electric field developed due to magnetic field. If magnetic field increases, electric field also increases. It depends upon the electric field on magnetic force. So that's why I will, basic idea I will tell you about. Since this magnetic force depends upon charge of the particle, velocity or drift velocity, and magnetic field, and sine theta. Sine theta, how this equation, how I can write in product, you all are about the force of the magnetic field depends upon the charge, velocity, magnetic field. And here we know according to Stephens the current is moving in this magnetic field. If you apply north side here, south point here, automatically magnetic field has start from north to south. So same here, magnetic field this direction, current is this direction, force will be in this direction. If I calculate here, if magnetic field here, current is moving here, force will be experienced. That's why this the responsible, that's why electrons are deflected. Electrons are curved in this direction. They are collected in the backside of this specimen, and front face positively charge collected. That's why the potential difference is developed. So this is the way you all know about the Hall effect. Now I will come some basic expression for and formula you are just how to know. So Fm, that is magnetic force, EVD into B. So sine theta, yeah, theta I am using 90 degree. Why 90 degree? Both all are perpendicular to each other. Here magnetic field and velocity are perpendicular to each. Magnetic field here, velocity is here, correct? So automatically they will be creating the 90 degree. So that's why sine 90 is 1. So EVD into B. So next, electric force. So E is equal to electric field. So EH, H means Hall electric field. So E is the charge. It depends upon these quantity. Electric field depends these two quantities. Next, so how much is the magnetic force? That much of electric force will be there, because electric field developed due to magnetic force. That's why magnetic force equation already we know. This equation is 1, I put this value, and equation 2 Fe, I put this value, E into EH. Now E get cancelled. Now I want to know about Vd. So that is drift velocity. E is equal to Hall voltage or Hall electric field divided by magnetic field. Now current flowing through the conductor according to Ohm's law, we know about I is equal to A, area of the conductor, and number of electron per unit volume, and E is the charge of the electron, and drift velocity. These all quantity. If you want to know how this quantity only came, if you want to know, just refer the PUC level books, because these all equation we can easily understand. You already know about that one, easy we can understand. So if current flowing through the any steady state of the conductor or steady state of the battery give flowing through the current in a conductor, it gives these values. These factors are depends upon the current. So I is equal to A. A is the area. Area how will come? Length into breadth. Here length I consider omega, and breadth I consider thickness, that is T. So omega into T and into Vd. Now we have to drift velocity. Vd is equal to EH. So EH. So Vd is equal to EHI divided by omega into Ne. That is here. Drift velocity is equal to I divided by omega t into Ne. Comparing equations 3 and 4. Equation 3 here, equation 4 here. Now I am going to put this Vd value, that is EH divided by B is equal to I divided by omega t into Ne. Now, but you have to know about EH, Hall voltage or Hall electric field is equal to voltage. So electric field developed here. So potential difference is Hall voltage, that is VH divided by length, that is how much is that difference is tells. So VH divided by omega. Using 6 and 5, VH divided by B omega is equal I divided by omega t into Ne. So easily we can understand VH is going to be here. So 1 divided by Ne. 1 divided by Ne is equal to Bi divided by T. So this is the Hall voltage expression. Now Hall coefficient. So 1 divided by Ne is the Hall coefficient. So is equal to VH into T divided by B into I. So you will just refer this one. 1 divided by Ne is equal to, I will move this equation VH. Here it come below B into I. Now Hall resistance. Hall resistance equal voltage divided by current is equal to, so VHO value already we know about that one. So B divided by N into E. You put this value in here, we get cancel I. So just finally we get B divided by N into T. This is the explanation about the Hall effect. Hope you can understand. Thank you so much.